Hello viewer, welcome to the video number 94 of the channel MALACHEMPHILIC. Video number 94 is the 35th episode of Chemical Thermodynamics. Topic of this episode is entropy and its significance. So let's start. So our topic is entropy. See, we know that if you take one cold body, say this is cold body, cold, and one hot body side by side, this is hot body, means they are in contact. So this is hot body. Then heat will flow from the hot body to cold body. It will never flow in the opposite direction, that is cold body to hot body. Now take another example. Say for example, this is water. Okay. Now here we have added some colored substance, say colored molecules. Okay. So as soon initially this colored substance or molecules of the colored substance are concentrated in one place. Now as soon as you are pouring it to water, then what will happen? Then molecule will disperse in the free space between the water molecule. They will occupy the free space between the water molecule. That means this one will just, these molecules will go and occupy the free space. But the reverse one, what is the reverse one? That means the molecules are randomly placed here, this colored molecule, but they will not get concentrated into one point like this. That means the reverse one is never possible. Means never possible. Here also reverse one never possible automatically or spontaneously. Okay. Then what is the reason for it? What can be the reason? Heat always flow from hot body to cold body, and this one, that is that substance, from the concentrated condition it will go to the dilute condition. That means molecules from the concentrated state it will go to the dilute state. That means the diffusion. All these processes occurs spontaneously. Now why these processes occur spontaneously, reverse does not occur? What is the answer of it? The answer lies in this thermodynamic quantity entropy. So I welcome all of you to this topic entropy. See, if you open any book and search for this significance or physical significance of entropy, you will find that it is written that entropy is the measure of disorderness. Disorderness or randomness. Measure of randomness or disorderness. So when disorderness increases, entropy increases. This you will find. And in all these natural processes are spontaneous, and in the spontaneous process this disorderness increases, so entropy increases. So this significance you will find in any book. But if you want to go in deep, if you want to know the depth of entropy, you must know the correlation of entropy with the probability. Entropy is denoted by S. S is equal to KB, Boltzmann constant, ln W. This W is this is the probability. So you have to understand this concept. Okay. Now, to understand this probability concept, let me tell you one simple example. Say, in one school building, 4 students are present. At some time, 4 students are present, and all 4 students are in one particular classroom of, say, 2nd floor. Okay, door is closed. So this is one arrangement. All the students are in one classroom. Now, if you open the door, make them free. Now they will move anywhere. Then it may happen one student is in the 3rd floor, one student 2nd floor, one student 1st floor, one student ground floor, or 2 students in one room of ground floor, one student in 3rd floor, one student in 4th floor, like that. So many arrangement of these students you will find it. Of course, this also will be one arrangement. All the students are in one room of 2nd floor. Okay, so a number of arrangements will be possible. So this number of arrangement in case of molecules, that means how the molecules are arranged in different arrangements, this number of arrangements are known as, or each arrangement is known as the microstate of the molecules. So in case of molecules, these arrangements of the molecule or different arrangement of the molecule is known as the microstate. So when all the 4 students are in one room, only one arrangement, that is the what is called, and the door is closed. So they are not free to move. Then only one arrangement. That means number of microstate is 1. But as soon as they are free, a number of arrangement, as I told you, is possible. So number of microstate increases or number of arrangement increases. That is, randomness increases. When the number of microstate increases, entropy also increases. Okay. So now correlate with probability. Probability in the sense that is when the probability of this existing, probability of the molecules of a substance in existing a number of arrangements, okay, then the entropy will be more. Okay, so entropy is related to the probability. If the probability of the arrangements of the substance or molecules, let us consider molecules are less number of arrangements are possible, then entropy is less. If there is a more number of probability, existence of these molecules in more number of arrangement means this probability will be more. When the probability is more, entropy increases. Now this is the concept. Now with this, we can explain this one. Say, this hot body, this is the hot body. Let us consider in the hot body, there are 4 molecules, right? Now, each molecule has some energy. Okay. Now, when they are moving, suppose if it is a gas, they will be moving. Even it is a liquid, then also they will be moving. So, if they are moving like this, then that exchange, even if it is a solid also, they will be vibrating, no? So, there will be a chance of exchange of energy like that. And because of all these things, one thing first of all you should remember, that each molecule has some energy, and you know energy is quantized. That means energy exists in a number of packets, small packets or energy packets. Say this molecule has suppose 20 energy packets, this molecule has 16, this molecule 25, this molecule has 30. Okay. Now, these energy packets in the hot condition, these energy packets of these molecules are arranged in a number of arrangements, or they exist in a number of microstate. So, when the substance is hot, then the arrangement of the energy packets will be more. That means microstates of the energy will be more. Okay, that means entropy will be more. Now, coming to the cold substance. Now, here also, this is the cold substance. Here also, there are 4 molecules. Okay, but each molecule has less energy. Less energy means less energy packets. Say this is 4, this is 5, this is 9, this is 1, like that. Okay. So, when there is a less number of energy packets, of course, they are moving and exchange of energy possible. With all these number of arrangement in which the molecules can, that means these energy packets can exist, that will be less. So, as the number of arrangements of the energy packet is less, their entropy is less. Okay. Now, when some of these energy packets flow from hot substance, hot body to cold body, then these energy packets are coming to this cold substance, that is cold body, and again this energy exchange will be possible here. In that case, more number of arrangements will be possible. That means number of microstate for the energy increases. So, entropy increases. Now, if I consider the reverse one, say if some of the energy packets moves from cold body to hot body, okay, which is not possible automatically or spontaneously, it needs the external aid. Say if it moves from here to here, then what will happen? After coming here, these energy packets, it will not increase the number of microstate. Already here it has more number of microstates for the energy. If some of the energy packets come here also, the increase in the number of microstate is very less. So, increase in entropy will be very, very less. So, this molecule, these energy packets will move from here to here, so that after coming here, the number of microstate increases. Number of microstate increases in the sense probability of these energy packets exist in more number of microstate increases. So, here entropy increases. So, this process is spontaneous. Entropy increases in the spontaneous process. And natural processes are spontaneous. Entropy increases in the spontaneous or irreversible process. So, conclusion is entropy of the universe, entropy of the universe continuously increasing. Okay. Now coming to this example. Here what we have seen that this colored molecule, this is water molecule, this is water molecule. Now this colored molecule, let us consider there are only 4 colored molecules. Okay, they are in the concentrated in one position. That means they have only one microstate. That means one arrangement. Now, as soon as you are pouring these colored molecules into water, then molecules will have a free space. They will occupy the space between the water molecule, free space, and they will scattered in different direction. Then you imagine you may get different type of arrangement. Say for example, these are the different space between the water molecules. So, these 4 molecules may be like this. These 4 molecules may be close to each other like this one. This is also one arrangement, no doubt. But the other arrangement also possible, more possible. Say this arrangement. Say these 4 molecules, one is here, one is here, one is here, one is here. Similarly, other arrangement also you can make it. Say. So now like this, so many arrangements of these 4 molecules. So one is here, one is here, one is here, one is here, like that. So many arrangements of the molecules between the free space of the water molecules are possible. So many arrangements possible means number of microstate increases. Number of microstate increases in the sense entropy increases. That means probability of this molecule to exist in a more number of microstate increases. So entropy increases. And obviously this randomness increases. That means entropy increases with randomness. Why the reverse is not true? Reverse in the sense these molecules, 4 molecules which are dispersed in that water molecules, now they will automatically go and combine and occupy in one place. This is the reverse state. That is not possible. This is diffusion. Molecules are going from concentrated state to dilute state. That is diffusion, which is spontaneous process. But the reverse one, from dilute to concentrated, that is not spontaneous, because if it goes from here to here, then once again you will get only one microstate. One microstate means probability of existing the molecules in a number of microstate is very less. Very less means this entropy is less, and entropy is more for spontaneous process, and entropy is less for less than 0 for this non-spontaneous process. So this is not possible. Understood? So entropy means it is related to the probability. Probability of existing in more number of arrangement or more number of microstate means entropy increases. And in all spontaneous process, this probability of more number of microstate increases, so entropy increases. Say in this case, what will happen? This energy, when it is going from here to here, hot body to cold body, then number of microstate increases means that energy is present in number of arrangement. That means energy become more, what I should tell that, scattered, okay, or spread out. Now just take the example from our life. One thing you remember, when energy is present in that concentrated condition, say in the sun, energy is present in the concentrated condition. That means number of microstate is less. Okay, then that energy can be used for doing the useful work. But when the energy is spread out, scattered, that energy is not useful. Okay, now we'll take the example, then it will be clear. Say all of us know that this plant with the help of carbon dioxide and water, it absorbs this energy from this energy packets or high energy photons from the sun, and it makes the food which is stored. This energy in the form of food is stored in the plant, and from the plant, when we eat this food, this energy is stored in our body. Okay, what is the source of energy? This sun. And the sun, I told that it is energy in the concentrated state or ordered state. In the ordered state, energy can be used for doing the useful work, right? That energy is stored in the form of food, and when we eat that food, that energy stored in our body, and then when we'll work, when we'll work, that energy is used, energy is released through work. That energy cannot be destroyed, cannot be created. So whatever energy present in the form of food, whatever we consume, that energy we use to do the work, then that energy is released, scattered in the universe. Okay, and when this energy is released while doing the work, that energy, which is spread out energy, is no way useful. That means cannot be used for doing the useful work. Energy is conserved, but that energy cannot be used. So in the universe, this energy which cannot be used for doing the useful work is continuously increasing. Take another example. Say battery. Okay. Now this battery, when you attach this battery, the bulb will glow. Okay. And when the bulb glow, this energy of this battery, energy stored in the battery, chemical energy converted to electrical energy, and then that energy, when it is coming to the bulb glow means it is converted to the light energy, heat energy, some heat is formed. That means this energy is scattered in the form of heat and light. So this scattered energy, which is released in the form of heat and light, cannot be used for the doing the useful work. So all of us, means all the animals, human being, we are nothing but this entropy generating machine. Through all our work, we are increasing that energy or disordered form of energy or scattered form of energy which is not usable. That means continuously entropy of the universe is increasing. And one day when it is reaches to the maximum value, equilibrium will reach, that will be the thermal death of the universe. There will be no energy which can be used for doing the useful work. The scattered energy, you cannot concentrate it. Concentrated energy can be scattered, become non-useful. But scattered energy, you cannot concentrate it. So entropy is very, very important topic. Okay. Because of entropy increases, as the entropy is increasing, continuously non-usable energy is increasing through all this spontaneous process. Hope you have understood. Thank you.